Good day, everyone. Today, we'll be speaking on algae derived biopolymers to replace plastic. We chose this topic because the environmental issues that we face globally are very prevalent, so we wanted to choose an engineering achievement that will have a positive effect on the environment. We narrowed it down to algae derived biopolymers based on the fact that it will be used daily, it has very broad applications, and it positively affects the environment.
When plastic mass production first started, they seemed an ideal solution for manufacture. Plastics are inexpensive, lightweight, durable, and corrosive resistant. Plastics account for 8% of global petroleum production and in 2009 amounted to 260 million tons produced. This is an industry that's growing currently at 9% annually. Unfortunately, some of the strengths of plastics are also a problem. They are very difficult to break down, and with a larger and larger percentage of plastics produced as disposable items, our landfills and oceans have begun to bloat with discarded refuse. Plastic debris has been found regularly in avian and marine life since the 1960s, and plastic leaching contributes to changing hormone levels, which disrupts plant and animal biologies. Bioplastics have great potential to alleviate the stress that end-of-life plastics exert on our planet.
The future of plastics lies in the field of biopolymers, with PHAs produced by cyanobacteria being a top contender for this century's next game-changing material. Cyanobacteria are single-celled photosynthetic organisms. PHAs, or polyhydroxyalkanoates, are produced by cyanobacteria, which is like algae, and is made of monomers, which are polymers that easily attach to itself at a molecular level. They can be long-chain or short-chain, with PHB being a short-chain PHA that is the most common PHA used in biopolymers. Being made of these monomers makes PHA bioplastics rigid to the point that they are comparable to petroleum plastics. What makes this technology so game-changing? Cyanobacteria need little nutrients and have a short life cycle, meaning that they require little energy to maintain. What keeps PHA plastics from overtaking modern plastics already is production. Scientists and engineers are still experimenting, and so far the right combination of species, environment, and nutrients has been yet to be found enough to yield enough PHA and cyanobacteria to produce that PHA.
The future of bioplastics holds great promise. However, they are being held back because of difficulty in producing large amounts effectively. The modern engineers that face this task are constantly pushing boundaries to derive better methods of mass production. A promising technique that modern engineers use is known as the two-stage technique. First, the engineers keep the culture of cyanobacteria in perfect growing conditions for the species of bacteria. Secondly, they restrict certain nutrients to bolster the accumulation of the PHAs. Engineers are constantly working on ways to make the perfect growing conditions and improve the accumulation techniques for higher yield. Within the near future, bioplastics will certainly replace the typical plastics of today.
The medical use B3HB and B3HBV has been intensively investigated in the development of various types of surgical material as same as BHA, which was tested for their medical use in surgical repairs. And also, European Bioplastic is currently working together with academics and 15 industry partner with 11 European countries in an effort to develop solutions for the bio-based economy of the futures. In addition, rising oil prices are attracting many large companies such as Meridian's US and Ecoman's from China to invest in PHA market on increasingly production capacity. According to e-commerce company from China, They manufactured 5,000 tons of PHA, which was the most applicant in Asia.
Claiming that something is the greatest engineering achievement is very bold, but we did so about algae derived biopolymers because it has many great benefits. One of these benefits includes the fact that it has broad applications and is not harmful to the environment. Algae derived bioplastic is a lot more beneficial for the environment than conventional plastic because it is relatively easy to be broken down. Replacing the conventional plastic with it will enable us to manufacture products that are made from plastic and needed for modern life while decreasing the harm that is done to the environment. The second benefit is the fact that it combats waste disposal problems. This is one of the main reasons for the research of biodegradable plastics. Algae bioplastics are biodegradable, which means that they can be broken down by bacteria. As previously mentioned, plastics are largely used, which result in a lot of plastic waste. Using algae bioplastics will help us reduce the space that the waste we generate takes up because they can be broken down relatively easy. And the final benefit that we'll be talking about is the fact that it reduces energy usage. Petroleum based plastics are expected to consume 20% of the global annual oil by 2015. But using algae based plastics offer a promising solution that will decrease oil consumption because the raw materials of bioplastics is not derived from petroleum.
PHA-based bioplastics are the invention of the century because it addresses this century's most pressing issue, climate change and pollution. This field is the culmination of thousands of people's livelihoods since the discovery of PHA production in 1966. It's an answer so big to a problem so monumental that it has taken decades upon decades and breakthrough upon breakthrough to bring to common reality. It truly will change the world. Thank you for listening to me and my group's presentation. Have a wonderful day.